Welcome. I'm an avatar designed by Yili Lin, a doctoral student at George Mason University's Department of Health Administration and Policy. Today, I'll walk you through how to describe data in R. Data exploration is the first step in any data analysis process. Understanding data characteristics helps prevent misinterpretations. Identify issues such as missing values, outliers, or inconsistencies early on. Summarizing data guides the selection of statistical methods and models to apply later. Clear data descriptions enhance the transparency and interpretability of your analysis for others. Loading your dataset is the first step. R supports various formats like CSV, Excel, and more. Inspecting data, head function returns the first 6 rows of the dataset, giving a snapshot of the data. Helps you quickly verify that your data has loaded correctly. Descriptive statistics is to provide a statistical summary of each column in the dataset, including measures of central tendency, spread, and distribution. Summary statistics provides the minimum, first quartile, median, mean, third quartile, and maximum for each numerical column. For factors or characters, it shows counts. Mean calculates the average value of a numerical variable. Median finds the middle value, which is less sensitive to outliers than the mean. Mode is the most frequently occurring value in a dataset. Unlike mean or median, R doesn't have a built-in function for mode, but you can create a custom function to calculate it. Works by finding the unique values in the dataset, counting how frequently each value occurs, and then returning the value with the highest frequency. Mode is especially valuable when dealing with categorical data, where mean and median may not be applicable. Standard deviation measures the spread of data points around the mean. Variance represents the spread of data points. It is also the square of the standard deviation. Range gives the minimum and maximum values of a variable. Describing categorical data to understand the distribution of categorical variables can include nominal or ordinal data. Key functions. Frequency table counts the number of occurrences for each category. Converts the frequency table to proportions, showing the percentage of each category. A bar plot helps quickly see the distribution of categories, making it easier to compare. Exploring data distribution involves visualizing and analyzing the distribution of a numerical variable to gain insights into its properties. Helps in understanding key characteristics of the data, such as its central tendency, spread, and the presence of any outliers. Histograms are useful for understanding the shape of the data distribution, such as whether it is normal, skewed, or has multiple modes. Box plots are excellent for identifying outliers and comparing distributions across different groups. Checking data structure is to understand the overall structure of the dataset, including the types of data stored in each column and the general layout of the dataset. Summarizes the structure of an R object, showing the type and a preview of the content of each column. Dim data returns the number of rows and columns in the dataset. In this case, the dataset has 20 rows and 3 columns. Column names lists the names of the columns in the dataset. Knowing the structure helps you understand the types of data you're working with, which is crucial for further analysis and transformations. Identifying and handling missing values in the dataset can affect the analysis if not properly addressed. Checks each value in the dataset for missingness, returning true for missing values. Sums up the total number of missing values in the dataset. There is none in this dataset. Dealing with missing data is crucial as it can lead to biased results if not handled correctly. Options include imputation, removal, or analysis methods that accommodate missing data. A detailed session on addressing missing values will follow. To explore and understand the relationships between 2 or more variables in a dataset, helps in identifying patterns, trends, and potential correlations that can inform further analysis. Correlation measures the strength and direction of the linear relationship between 2 continuous variables. In this dataset, the variables zocor and nucor have a correlation coefficient of 0.34, suggests a moderate positive linear relationship between these 2 variables. Scatter plot, a graphical representation of the relationship between 2 numerical variables, often used to visually assess the correlation. Are effective for visualizing the relationship and identifying any potential outliers or patterns. The scatter plot of zocor versus nucor doesn't show a strong linear relationship. The points are scattered widely, with no distinct pattern that suggests a strong connection between the 2 variables. This aligns with the moderate correlation coefficient of 0.34. Describing data is a crucial step in data analysis. R offers a comprehensive set of functions to explore and summarize data effectively. Understanding the characteristics of your data guides the subsequent steps in your analysis.